you're going to be receiving your BlueMicro, you're going to be receiving also a programming kit. And here's what's included in the programming kit. So first piece is going to be this J-Link. This one is a pretty inexpensive Chinese clone. You're going to get a serial adapter. You're going to get a little bag of Dupont connectors, or at least shells, and then 2 sets of wires. So what do we do with all these things? First things first is what we're going to do is we're going to actually configure these cables so that they're much easier to use on a keyboard. Same with this one here. So where do we use these? So let's first open up the J-Link that usually comes already pre-packaged on something like this. So what does it look like? So this one is a very inexpensive Chinese clone. There's a number of versions of these. This is probably the least expensive one. Typically you only need to use it once when you need to flash the bootloader. After that, we're always going to be using the serial connector, the serial adapter. So let's first start with the bootloader. Now this is a J-Link that's used for flashing ARM microprocessors. You're going to see on here there's a number of signals. So there is VCC, there's ground, SWCLK, and SWEIO. So essentially this TVCC that detects that the device is powered on, GND, that's the ground, like the 0 voltage signal, then a clock signal and a data signal. On the other side, you're going to have the same labels of here for each of the pins. So these line up with the pins. So we have 4 wires. Now on a BlueMicro, what you will also see, and let me just grab some pre-assembled BlueMicros. On a BlueMicro like this, you will see there is essentially the E73 module right here. You're going to have, this is a charging chip for the LiPo battery. This is the voltage regulator. And right on here, we've got a 6-pin header. 2 are for the power, 2 are serial lines, and then 2 are for the programming signals. Now, of note is these programming, the SWD programming is very different than what we use for AVR controllers, like the typical 80 mega. So if you already have a AVR programmer, it will not work because it's a different protocol, it's a different set of signals. So going back to this here, we have 4 wires going to, and if you remember on Ergo Travel, you're going to see the BlueMicro either this way or this way. So that means that the orientation of the power lines and the data lines are actually going to be reversed depending how you look at it, on which half. So that means we cannot have a simple 4 pins. We need to have 2 individual pins. Now, let's have a look what we've got here. So that means on one side, we're going to be using 2 independent shells like that. And then on the other side, we can use a standard shell that does not move. So what we're going to do is we're going to take a 4-wire Dupont cable. And these little single shells, we're going to remove them. And we're going to replace them with these shells here. We're going to replace them such that they're easy to never have to remember exactly how they go in. Now what you can do is use colors for whatever makes sense for the signal. So what I usually do is take the red for the VCC and the brown for the clock. Your wires colors may be different, so just choose a color that makes sense for you. Now, whenever we're going to go to the serial connector, now we're going to do something very similar. We don't generally need this jumper. This jumper typically is used between the RX and TX signal just to have a loop back. So whenever you you go in a terminal session and you actually type in, it's going to automatically come back and whatever you type gets returned. So we don't need this this jumper. However, again, very similar to what we had before. There, as you can see, there's a 5 volt VCC, 3 volt TX, RX, and GND. So we're not going to be connecting any of the voltage. So what we're going to do is we're going to have 3 wires, one ground, the RXD, and a TXD. So let's put that aside. Now, you're going to get a 3-wire female to female connection. Now, why female to female? We have the male connection here, but including in the kit, we have a little angle connector like this that we solder on the board. This is included specifically for the ergo travel, and you can, if you have a different board, you may not have this connector, so you may have to go directly again to the serial and the TX lines on here. So I'm going to show you later on where that goes. So let's first start on the SWD lines for this. So what we're going to do is we're going to use this here. So for this, what we do is we take our Dupont Shells, and here I have a very, very sharp tweezer, and I'm going to just point into it and remove it. So point, remove, lift the little tab, remove, lift the tab, pull, and we're going to do the other side too. Lift the tab, pull, lift the tab, pull, lift the tab, pull, and then finally lift the tab, pull. So these you can throw away, we don't need anymore. So now we're left with just the wires with the connectors. So what we need to do is these are going to come here into that 4-pin. Now if you look carefully, there's a side with large holes and a side where the pins go through, and very similarly to the previous ones, we've got a side where the little hooks. So if you look carefully, you're gonna see that there's it fits only one way. So the side where you see the crimp on top is where it goes and lock into the shell. So I said the second line is ground, brown, dirt, sounds good, so I'm going to put that as a second. And as you pull, now it locks in. Then I said the red is going to be my VCC, so I'm going to take my red as my first pin here. Then I've got my clock and IO line. Now for these two, I've got yellow and orange. It doesn't really matter which color goes where. And I just slide those in again. Okay. Now on the other side, if you remember earlier on here, I talked about having the mirror between either the left or the right. So that means we'll have to flip the wires around. So having a 2 and 2 shell, so what I usually do is I take my 2 power lines, and it doesn't really matter which one goes left or right because they're going to be easy to flip around because it's only 2. Just load one, make sure it's locked, load the next one. Sometimes they're a little bit trickier to get in. There we go, push it through, make sure it's locked. So now I've got the first set of 2 loaded up. Then I have my second set. And again, 2 pins. They go right in here. So the first one gets loaded up. Oops, gotta be square in here. And then the next next one. Okay, so now these are connected. They're rigid. Now, why do we do this? Instead of having to deal with single wires, now what we can do is say, oh, well, I've got my red. It lines up with VCC. And I connect all four all at once without having to think about it, to have to like line up which one goes where. And then for these two, all I need to know is like my IO line is the yellow, the bottom one I've got here. And then when I'm going to go and program, and let me switch this here so you can see a little bit more zoomed in. So whenever I go and program, is I take the middle one is my VCC and ground, so it goes in the middle. And then my IO and clock lines go closest to the chip, and that goes right here. So I'm going to have something that looks like this when it's ready to program. Okay. Now obviously it's not plugged to a computer yet, so we're just going to leave that aside. So this is what my programming jig is going to be looking like. So let's move that aside for now and go back to all. Now let's see this about the serial lines. So I've got 6 here. So I've got a shelf with 6 that goes right on top like this. But then I've got a shelf of 4 for 3 wires. So what we need to do is figure out where do each of the wires go. So what I'm going to do is I'm going to take like one of the 2 halves of my ergo travel and I'm going to open it up. Now, let's see. So here's the ergo travel as it looks on the inside. So you can see I've got a battery already. I've got my chip on here already. So you can see right here I've got already soldered my power pin, and I've got a little dot just on the edge of the PC board to kind of remind me which side is the switch on and which one is off. And then you can see right on this edge here I've got ground, reset, RX for receive, TX for transmit, and then a VCC. Well, this is where these little pins are going to go in, and I'm going to solder them. I won't do that quite now, but I soldered them right here like so, such that the ergo travel always going to have an easy access for these wires. These are my serial programming line. It's going to be coming in on the inside, so I need to open up this for me to program it. But it's going to be coming up here such that I have my ground. I don't need a reset. I have transmit and receive. So similarly, I'm going to remove these little shells. So lift, remove. Again, I remove everything. Lift, remove. Lift, remove. Go to the other side. Lift, remove. Lift, remove. Lift, remove. Now I've got 3 wires, and they need to go to ground, receive, and transmit. So now I've got to pick a color for ground. That's something that I somewhat remember, so I'm going to say ground, and more negative, I guess. That's not a positive voltage, so I'm going to say black. So the black one is going to be on the edge of my 4-pin connector. So let's go and select that one, my 4-pin. Go on the edge. Okay. Then a reset. I don't have a reset line coming from here, so I'm going to skip it. Then I have RX for receive. So I'm going to take the gray one on here, on this side here. because the arrow travel receives, and then whenever it transmits, it's going to transmit over the white. So what I do now on the other side, so I've got, if you see here, I've got a crossover. Now on this side, it's going to go with this one here. So at the bottom, again, very similar shell. Now this one was like this, so ground, and I decided my black one was ground. So the black one, I think my black one here, and I decide black one is ground, and it goes on the edge. So this is the first one, black ground. Okay, then the receive is the next one. Now receive here means transmit here. Transmit here is the one on the edge. It's white. So white is the next one here. So slide the white one in. Okay. And then the next one over is transmit. Transmit here is receive here. So the second pin here. Okay, so that's where it's good. So everything's locked in place. So now what you can see here, I've got my black one is my ground. That goes on the first pin here. The next one is receive. The next one is receive, and that goes to transmit, which is on the far here. Then I've got transmit here, which goes to receive here. So this is where I've got my cross. Now when I'm going to want to program my BlueMicro, this is where I come and go and plug this right in here so that I can come up. So it inserts right in here. And there we go. It inserts right in here, and it's going to be tight fit with the if you've got an internal case like this. And then on the other side, this is where you're going to have this one here. Remember, black for ground, as I indicated. So you plug it in like so. So this way, again, don't have to remember which pin gets where. It's already set within the connector. So we're going to be using that later to program our chip. Okay, so this ground to the black, so you can leave it pretty much permanent like these two here. So now we've prepared